and welcome to the Invasive Species webinar series. I'm your host, Courtney Chambers from the Earth Environmental Lab. We're going to be learning about a second green algae species discovered in Oahu and the implications for native habitats in the Hawaiian Islands today. So I'm glad you're here. Okay, at this time, I'd like to introduce our speaker today. Mr. Kevin Foster is a marine biologist in the U.S. Army Corps of Engineers New England District. Prior to his position with the Army Corps, Mr. Foster spent 21 years with the U.S. Fish and Wildlife Service's Ecological Services Division at the Pacific Islands office in Honolulu, Hawaii. In Hawaii, he had the opportunity to work in several programs, including Section 7, vertebrate recovery, and contaminants. But he spent the majority of his career in the Conservation Planning Assistance Program, FWCA. During his time working on FWCA 2B, he worked on several islands in Hawaii, Guam, and American Samoa. Mr. Foster also led many marine surveys, which you can see in his bio posted on my Gateway, and he became involved specifically in marine invasive species issues in Hawaii and worked with colleagues to raise awareness among the scientific community and the public by kickstarting an invasive species workshop in 2001. More information about Kevin can be found in his bio posted on the Gateway, along with the slides from today's meeting and the recorded webinar. Mr. Foster, we're very happy to learn from you today. At this time, I'm going to give you the presenter rights, and we can begin.
How's that?
Yes, that's great. Thank you.
Okay, super. All right. Well, thanks again, Courtney, for all that you've done to help support and prepare for today. I appreciate it and appreciate the opportunity to talk about a really important subject, invasive species, and particularly in Hawaii. And so I'm just going to talk briefly about our objectives for today. I imagine most of you know where Hawaii is, but we'll do a little bit of a review here. We'll talk about coral reefs, provide a quick overview. Some of you may have seen or learned about coral reefs, and having that understanding of the ecological value and the role they play in our nearshore marine tropical environments is going to help you understand the magnitude and the risks that invasive species play. I'll also provide an overview of invasive species in Hawaii, and then I'll get into the specifics of the new species, the new record that we have for Hawaii, which is Avonvillia erecta. And we'll then move on to implications and the threats that invasive species, in particular Avonvillia erecta, may play in Hawaiian coral reefs, and then we'll talk briefly about any recommendations. So aloha to everybody, and I want to give a big shout out to the Honolulu District, if there's anybody on the phone from there. Honolulu District working with the Fish and Wildlife Service and NOAA, as well as our state of Hawaii biologists, American Samoa, Department of Marine Resources. Samoa is down here. Guam, the territory of Guam is over here. And Saipan, Commonwealth and Northern Marianas, is over here. And this is one office, one district, working with other federal partners, state and federal agencies, working in an area 3 times the size of the continental United States. And we have a unique relationship with our partners, and it's a real collaborative one. And we get a lot done with very few people out in this area. So the other thing I'd like to say from a biological standpoint is that the Hawaiian archipelago, which is located here, you see my cursor, there's a fairly large gyre hovering above the archipelago, and that helps pull currents from west to east, and basically are bringing species from the Western Pacific over to Hawaii. Now, in conversation with scientists over the years, and I can't attribute this to any particular scientist, but my understanding in prior to human human presence in Hawaii, that a species made it to Hawaii once every 10,000 years, and scientists are making this estimate based on carbon dating and so forth of reefs and as well as terrestrial species in Hawaii. But we're about 2,500 miles from California, and another 2,500 miles or even longer over to Guam. So we're right out there in the middle of nowhere. This is the Hawaiian archipelago. It's about 1,600 miles in length. We've got the Big Island in the southwest or southeast corner, and Curie Atoll in the northwest corner. Curie is about 30 million years old, something right around in that area. The Big Island is about 500,000 years old. In the evolution of a coral reef, you've got fringing reefs that are forming. They're newly formed reefs within the main Hawaiian Islands. We're absent any of the middle-aged coral reefs that have a volcanic landmass and a lagoon combined. We just have the younger fringing reefs and then the older atolls where there's absent any kind of high island, and you're just basically that has disappeared. And coral reefs are building up these barrier reefs over time and keeping up with sea level. This is a depiction of Oahu Island, and just some highlights here. This is Honolulu Harbor, commercial harbor here. This is Pearl Harbor, home to the Pearl Harbor Naval Facility over here. And over here you have Barbers Point Deep Draft Commercial Harbor. This is the southern side of the island, the western side, eastern side, and this is the northern side. So if you can keep that picture in your mind, I'll refer to it later. Here's a close-up of Honolulu Harbor right in here, and I'll reference that. This is where we found Avernvilia erecta, right in this area where my cursor is. And Dr. Rachel Wade made her discovery of the same species over in Key Lagoon to the west of us. Now, I would also like to draw your attention to the fringing reef. As I mentioned here, this is basically a coral reef in its infancy. Oahu is probably 2 to 3 million years old, and you see basically the growth of a coral reef right in here. In time, Oahu will disappear, and as it moves up the archipelago, and you'll see this fringing reef form a barrier reef, and inside here, this will all become a lagoon. So coral reefs, what is a coral reef? And so we'll spend a few minutes talking about what a coral reef is and what it does, and that'll really help you understand, why we're so concerned about invasive species. Coral reefs are geologic structures that are comprised of calcium carbonate material that is laid down by a thin veneer of animal tissue known as a coral polyp. You can see here that all the structure, as far as the eye can see, it is all calcium carbonate. It's a stony reef. You've got lobate corals in the center. You've got branching corals, plate corals. In the foreground here is a plate coral. And you've got these weedy branching corals here, Poecilophora meandrina. Porites lutea is the big lobate coral. That's probably about 3 to 4 meters across. And then I will come back to this a little bit later, but you see all this orange stuff on this plate coral. So this plate coral has run its lifetime, and it is expired, and it is now covered with crustose coral and algae. And I'll talk about that a little bit later. Corals gain their nutrition in part through filter feeding, as well as from a symbiotic relationship that coral polyps have with a microscopic marine plant, dinoflagellate, called zooxanthellae. Now, polyps are coral polyps are filter feeders, just like any other invertebrate. Most invertebrates are filter feeders, and so it's gaining some of its nutrition from that process. It's also gaining nutrition and nutrients from the products that the plants are basically producing. And so without that, without dinoflagellates, zooxanthellae, and that mutualistic relationship, the corals would be bone white. There would be no color. The zooxanthellae give a coral its color. So the coral that you see here on the left, Montipora flavellata, is purple, and that's basically the color of the marine plant. You'll see this brown color over here. Again, that is the marine plant color that you're looking at. And so corals are very delicate. There's a delicate balance and a relationship that they have with zooxanthellae. A few degrees warmer or a few degrees cooler, and the coral polyp will expel those zooxanthellae, and it'll try and acquire another suite of zooxanthellae that are adaptable to that temperature. If they cannot do that, they'll basically starve. And that's what, when you see in the newspaper coral bleaching, that's really what the cause is that change in temperature. So requirements for corals to flourish and reproduce. Corals require clean water quality conditions, free of sediments and contaminants and excess nutrients. Coral planula or larvae require clean substrates to successfully attain settlement. Basically, if you can imagine this coral planula larvae swimming, it's got a motile stage, and it's searching for a place to settle and grow into a mature adult. And so on the left photo, we've got this Postulopora meandrina colony. It's a small, young, fast-growing colony, and you see this bubblegum color encrusting, stuff on the reef here. Well, that's a plant, and that's crustose coral and algae. And so the planula is looking for a clean place to settle, and it's looking for the chemical cues that are emitted from this plant. Now, on the right side, you'll see all this coral rubble, and rubble is very common on a coral reef. Storms knock off branches, corals die, and they accumulate. Well, the pink stuff that you see on these branches and pieces of rubble, that's all crustose coral and algae. And if left alone over time, this will all become a cement plate. And so it's the algae working in combination with coral to really form the reef and keep the reef intact. So coral reefs support thousands of species of plants and animals. They are, in Hawaii, we have approximately 50 species of corals. As you move to the Western Pacific and the Marshall Islands, we've got about 300 or so coral species. By the time you get to Palau, it's up to maybe 600 or 700 species, and then when you get to the Philippines and Indonesia, you're well over 1,000 species. On the photo on the left, you've got a nice variety of reef fish, soft corals, and some fast-growing hard corals. And on the photo on the right, you've got a mix of soft corals, as well as a lot of species of fish in the water column, and they're doing their thing, eating and reproducing and so forth. In this photo, we're highlighting another function that coral reefs provide, and coral reefs are important. They provide important functions for reproduction, forage, resting, and shelter from predators. And so The apex predator on this particular reef is a gray reef shark. Other reefs up in the northwestern Hawaiian Islands, sharks are not the apex predator. Carangids, large jacks, they go about 150 to 200 pounds, and they're the bullies on the reef up there. Hawaii is the endangered species capital of the world, and coral reefs support some of these species. On the left, you see the threatened green sea turtle, Chelonia mitis. The Hawaiian name is Honu. On the center photo, you've got a hawksbill turtle, and it's resting and hiding away from from predators. And on the right, you've got a small octopus nestled in my hand. I was able to get a nice photo of that. Coral reefs also support endemic species, and in Hawaii, up to 1/3 of all marine mollusks in Hawaiian waters are endemic, and it's been cataloged that over the 7,000 Hawaiian marine species, about approximately 1,250 are only known to occur in Hawaii. So coral reefs are providing a lot of function for natural resources. For birds, seabirds are foraging in nearshore coastal waters. They're looking to pick off fish or invertebrates to sustain themselves and their chicks. For human residents in coastal areas, and in Hawaii, everybody's living on the coast, and there's plenty of coast. And coral reefs function, provide a real important function as buffers between large oceanic swells, and by diffusing wave energy and reducing the risk of erosion. Without intact coral reefs keeping up with the surface sea level, you lose that really critical function, and waves would no longer be impacting on the reef, but they'd be rolling right in and impacting on the shoreline, and that would exacerbate erosion. Coral reefs support multi-million-dollar recreational industries, boating, surfing, fishing, scuba diving. And in Hawaii, that's a very big business. Guam, Saipan, supporting tourists from China and Japan. It's a very important, lucrative business for them as well. Millions of subsistence fishermen rely upon coral reefs for their daily survival throughout the Indo-Pacific, Hawaii, Polynesia, Melanesia, into the Indian Ocean. There are a variety of third world countries that their populations would suffer greatly if we lose coral reefs. So, Courtney, that was just a pause for me. If anyone had any burning coral reef questions, okay. I'd be happy to take anything if you've received any questions so far.
Okay, I haven't yet, but that's a good reminder to invite everyone to type in their questions, and we'll get to them as we go through. Thanks.
Sure,
if not, we'll
absolutely.
handle them at the end.
Right. Okay. So moving right along here. Species dispersal and invasives. So we're kind of turning the corner here. We're going to focus the rest of the talk on invasives. So drifting organisms began colonizing the Hawaiian Islands soon after they were formed, and this process has been ongoing for millions of years, leading to the evolution, as I mentioned, of endemic marine, freshwater, and terrestrial species in the Hawaiian archipelago. It's an incredible scientific experience, and if you haven't been to Hawaii, I'd encourage you to go. It's one of the most isolated islands in the world, and a great many species didn't make it and naturally colonize because of the great distances. And human intervention with boats and airplanes and so forth have made that process of species arrival much easier. And according to Carlton Eldridge, over 300 aquatic species have been introduced to Hawaii, and there are an additional 100 species that are considered cryptogenic. And cryptogenic is basically scientists are not able to determine whether the species arrived naturally to Hawaii or if it was introduced. So I would like to highlight of those 300 species. I've picked 5 of real bad actors that I'd like to talk about, and then we'll get into Avernvillia erecta. And these real bad actors are Avernvillia lacerata. For many years, it was known as Amadelpha, and that recently changed. Gracilaria salicornia, Hypnium muciformis, Acanthophorus spicifera, and Capophycus alvarezii have really laid low coral reefs around Oahu, Maui, and Kauai. So for me, the most insidious of all these species is Avernvillia lacerata. It was introduced in 1981, we suspect, through Honolulu Harbor as the point of origin. It showed up on the leeward side of Oahu. It has incredible range for an alga. It's basically invaded both hard and soft substrate, sediments, sand, mud, as well as calcium carbonate reefs. It's got a really strong hold fast. Again, it has made it into the upper intertidal, as well as, and it's been documented down to at least 130 feet by Kim Payton. And it has also shown up over on Kauai. For Oahu, I've been able to define the range through some of the work that I was doing recently for the Marine Corps, and it is showing up in just south of the Marine Corps on the eastern side of Oahu, and Kim and I have both documented its expansion up the western coast of Oahu on the Waianae Range over there. The plant consists of 1 to 4 blades, really strong hold fast, and it has been documented by Kim and others to outcompete native algae and seagrass. It also alters habitats by trapping sediments, and it acts as a secondary substrate, serving as a substrate for the epiphytes of other species of algae. Gracilaria salicornia is successful in calm, protected waters, disperses through fragmentation. It was introduced by a professor at the Hawaii Institute of Marine Biology back in 1978 for aquaculture purposes. And so during the 60s and 70s, there was a real mentality of, hey, let's bring everything we possibly can bring into Hawaii. Most notably are wallabies that the state of Hawaii brought in. Dave Woodside, who is a state biologist, brought him in the early mid-60s, I believe. And then Dave came to work with the Fish and Wildlife Service towards the end of his career and the end of his life. And we worked together to undo some of those introductions that he was involved with earlier in his career. Gracilaria is found in reef flats and eroded limestone mid-intertidal pools up to about 12 feet deep. They're comprised of solid cylindrical branches, 1 to 2 meters in diameter with short pointed tips. And they also compete with a native limu, native algae that are consumed by Hawaiians, and that's Gracilaria coronopilofia. It's a mouthful. And so from a Hawaiian perspective, Gracilaria salicornia is directly threatening, their culture, eating native limu is real important to them for a variety of reasons. Hypnia muciformis grows rapidly. It's abundant, and it supports other algae species. They're epiphytes. It easily fragments and disperses, and it's found on Kauai, Oahu, Molokai, and Maui. And it was also brought in to Kaneohe Bay through HIMB for aquaculture purposes in the mid-'70s. It flourishes in calm, shallow waters, and it also will mass and float. And so on Maui in particular, during the winter storms, these masses of algae will mobilize, and they'll create windrows on the beaches, and they produce a real foul smell, and they're very itchy for swimmers too. So it's a real nuisance species, and impacts the tourism industry on Maui.
Kevin,
sure.
What kind of aquaculture was the intent for, or what takes place there at Hawaii? What kind of aquaculture?
Sure. Well, there, for the next species, Capophycus, I know for sure that was used for the ice cream industry. I didn't get the gist on what the other species were, what they were intended to target. It could have been as food for pigs as well. We've heard that some algae have been used to feed pigs, but I think it was Eukema. Was their goal, is to get that going to support the ice cream industry. So I think that was the grand plan back then.
Thank you.
Yeah. Yep. Acanthophoros spicifera was brought in on a barge from Guam in the early 1950s. And this invasive alga is ubiquitous throughout the main 8 Hawaiian islands. It's very abundant in shallow tide pools, rocky intertidal areas, hard substrates. It's brittle and fragments, and it has short, compact, very dense thalli. And they move around, and they are known to compete with native Laurencia, and there is a native Hypnia species as well. And so Capophycus alvarezii is the largest of all the invasive species. It can grow up to 6 feet tall. It has incredible growth rates. It can double in size in 15 to 30 days. It was also introduced in the 70s for aquaculture, and I know for sure this was the ice cream industry. We're looking at using this to keep ice cream firm, and so Capophycus alvarezii is you can see on the right-hand photo that it's growing up and over and around this coral, and the coral is pretty much it's in its death stages right there. It's all bleached out and dying. So that's what the top 5 worst corals or algae have done to coral reefs in Hawaii. And we've been tracking them for decades. Scientists have been tracking them for decades, and they've had magnificent impacts on coral reef communities. There have been a great public response to this. Credit to the Hawaiian community and the residents of Hawaii, from Boy Scouts volunteering to pull algae, to scientists evaluating mechanisms for removal, mechanical and chemical and so forth. So the fight goes on, but now we've got a new species to deal with. And so this is Avernivillia erecta. And so this species was observed during a survey that the Fish and Wildlife Service was performing for the Honolulu District Civil Works Office. And it just so happens that on that dive, we're lucky enough to bring Dr. Kim Payton along, as well as the Paul Murakawa, who's the dive safety officer with the Division of Aquatic Resources with the state of Hawaii. We were doing some sampling. The intention of the survey was to look at seagrass and get densities and aerial extent and so forth for some planned maintenance dredging that the Corps had coming up. The Esseons was going to be brought in 2016 to do some maintenance dredging in the entrance channel and the turning basin, and this is all in preparation for that. The second observation of Avernvillia erecta occurred by Dr. Rachel Wade in April of 2017 in Kea Lagoon, which is slightly west of Honolulu Harbor. And Rachel was also looking at similar habitat. It was sediment, sand, soft sediment, and there was seagrass, as well as calcareous green algae, Halimeda conoluana, in the area. So some more information about Avernvillia erecta. The two morphologies were observed during both surveys, and individuals were completely illustrated full blade development, and there was also another form that involved the loose assemblage of siphons. The photo on the left is the full blade, and the loose siphon is on the right. Of course, the larger individuals had that full blade development, and they were actually perched up on sediment, and they were forming a little mound around them. And we're finding the loose siphon probably in a little bit calmer waters, and we're not quite sure, why this different morphology was presenting itself here. But you can see the Avernvillia erecta here, and then these small blades here. This is actually seagrass, and so this is a close-up shot of Halophila decipiens, which is indigenous to Hawaii. There's a endemic gastropod, Smaragnia bryani, that can only be found on seagrass. Talk about that a little later. Anyway, the holdfasts are large. More mature individuals protruded from the sediment, approximately 1 to 5 centimeters, creating a conical mound at the base of the algae. The photo on the left here illustrates a fish bite. So there are some fish that are interested in this, and you can see right here real clear fish bites. So that's good news that we may have some natural predators. But again, the concern is that if we are seeing these individuals group up and get into pretty significant densities, there is a possibility that there may be epiphytes and a flocculent canopy forming, and that would be disastrous for the seagrass, and that would mean that they're being outcompeted. Rachel took this photo, so you basically got the blade and basically the stalk, here, and so this is what we observed, and we pulled that out actually, and I'm basically holding this, and you're able to see the blade and the stalk here in the holdfast. We did measure that later on. 46% of the plant was basically holdfast, so it's pretty substantial. Adult individuals ranged in height from about 6.5 to 15.5 centimeters. Their fronds ranged in size from 3.5 to 10.5 centimeters. Juveniles consisted of a holdfast and a spherical assemblage of loose siphons, and we were able to confirm that both samples from Honolulu Harbor as well as Kea Lagoon were identical, and those were basically they are the same species. So shifting over to what does this all mean for Hawaii, and what are the threats that face coral reefs in Hawaii? So invasive plants are threaten the coral reef communities by outcompeting native seagrass and algae. And in Hawaii, again, that there are endemic gastropods. I use an example, Smaragnia bryani is only found on seagrass, and so if we're going to lose communities of seagrass, we're also looking at the potential of losing native gastropods and other species that rely upon seagrass. Invasive plants grow in dense patches that support epiphytes, and these epiphytes are not checked, they're unchecked, they're not consumed by fish, and they create a flocculent canopy, and you get this soft, mushy substrate in which corals and native algae are not able to occupy. Invasive species also threaten endemic corals such as Montipora capitata and Leptoceros hawaiiensis. And they also degrade ecological functions such as species reproduction, forage, resting, and as well as shelter habitat. So if you remember that Avernophilia lacerata photo that I showed you with the measuring stick, the black and white measuring stick earlier, and that close-up of the Avernophilia and the flocculent community. Well, this is a panorama view of that same area. And so this expansive area here has been invaded by Avernophilia lacerata. And you see some remains of, dead corals here and there that are, they're here and there, but the flocculent community is just dominating, and underneath that you've got Avernophilia lacerata. And so we've lost this entire community here to one particular species, and that is basically doing, unless we're able to mechanically remove Avernophilia from this area, we're not going to get this reef back. So what does that mean for Hawaii? And so the resiliency, as we lose resilient coral reefs, we're going to lose that wave energy function, and we're going to see an acceleration of coastal erosion. And to throw that on top of elevated sea surface levels and other effects of climate change, we're going to see greater threats to residential homes, coastal roads and infrastructure, military installations, and commercial industries. And I want to highlight the military installation that is probably most vulnerable to sea level rise and invasive species is the Marine Corps Base Hawaii. And I've actually been doing a tremendous amount of work in the past with Dr. Diane Driggett and Lance Bookless to document their resources all around the base. This is Makapu Peninsula, and you have tremendous activity here. You've got a helicopter pad where over here where pilots are flying all the time. You've got a runway where P-3 sub-hunters are running off of. You've got a 1,000-meter range here where all sorts of ordnance are being tested and fired, and FBI range over here. And all of this is vulnerable to erosion. There's significant erosion going on in the eastern side, and you've got erosion going on up by this helicopter practice run over here. There's a lot of Gracilaria acanthophora up in this area, and then you've got Avernophilia lacerata moving up the coast along here. And so these are real threats, but the Marines have taken an outstanding posture. They're fighting this like they would any other fight, and they're taking it real serious, and they've invested a lot of time and energy and funds into working with the University of Hawaii Bishop Museum to come up with methods to remove algae and protect their coral reefs, because they get it and they understand, what an intact coral reef means to their survival and their existence and their mission. So for Hawaii, these are just some of the recommendations that would make sense to deal with invasive species. First and foremost is to identify hotspots within Honolulu Harbor and identify the presence of newly established species and conduct inspections on an annual basis. Dive teams from Bishop Museum or University of Hawaii or Fish and Wildlife Service, NOAA, State of Hawaii all have divers to do this. And so this would be a real positive step to get out there and spend a day or two once a year and looking for invasive species. If there are species that are detected, have a rapid response team and use appropriate methods to remove and contain and eradicate incipient populations. 80% of all materials that come to Hawaii pass through Honolulu Harbor. Now, not many people know this, and certainly the public doesn't know this by and large, but Hawaii only has 30 days of food. There are 1.3 million people that live throughout the state of Hawaii, and they've got 30 days if their harbor if Honolulu Harbor stops working for whatever reason. And so to take this, to the next level and protect it, certainly there are a lot of threats. Invasive species is just one of them. But periodically inspect inter-island barge vessels for any invasive species that could potentially radiate from Honolulu Harbor out to any of the other neighbor island harbors, Kalaihai, Kahului, Hilo, or Nawiliwili harbors, and to inspect those harbors as well. We've had several introductions on the hulls of barges, and it would make good sense to inspect any barge that's coming from really anywhere, from the continental U.S., Asia, South America. And lastly, we need effective laws to hold dirty barge owners or anyone really responsible for introducing invasive species, because these days, to be able to obtain funds to do the research and develop the methods and combat and implement removal activities, it's a lot of money, and of course funds are absolutely scarce. And so this is the dive team that found that species back in October when they were doing survey work for Honolulu District. And you've got Dr. Kim Payton up there on the top, and Paul Murakawa with his bag, and then I'm hanging out. So any questions, Courtney? I'd be happy to take any questions.
All right, great. Thank you very much, Kevin. At this time, if you'd like to unmute your phone line, we can have you ask your question verbally, or you're welcome to continue utilizing the chat feature to ask those questions. Kevin, to kick us off, I was curious, what does mechanical removal of an algae species look like? How do you do that?
Okay, so in its most basic form, mechanical removal is basically a diver going down and pulling the plant out, and it has to be done completely. If you have to completely remove the holdfast. If any bits or pieces of it are left in the reef, it'll simply revegetate, and so it's getting in there in some cases with pulling the plant out, then using precision equipment, almost comparable to a dentist scraping out bits of plant tissue and capturing that and either getting that into a bag or if you're lucky enough to have a suction device. Now in Kaneohe Bay, the Nature Conservancy teamed up with the state of Hawaii, and they were running on a weekly basis for many years, actually, removal process using divers in the water and a suction platform to suck up Kappa ficus, Gracilaria, Acanthoptera, etc. And so that was a real effective method.
Wow, that sounds tedious.
Yeah, it really is. And to be thorough, it takes a lot of man hours. It's very expensive, and prevention is much more desirable than to have to deal with it later on in removal.
Okay, and maybe this is silly, but are there any chemical options? I assume not, because corals seem sensitive.
Okay, so there really are no chemical options. So there is an infestation of an invertebrate, almost like an anemone in Palmyra, and it has actually outcompeted everything. It's in great mass, great densities, and acres and acres of this invertebrate that's outcompeting corals. And in that situation, a very dire situation, they've experimented with pumping chlorine, containing it under mats, putting out these tarps, etc., and then pumping chlorine in. And you basically kill everything, and then you let the reef try to recover after that. That's one example of using a chemical method.
Wow, so it has to be kind of a dire situation, I guess, before you would consider that.
Yeah, exactly. Yeah.
Okay, just to touch on the other form of species control, does it matter in the case of algae like this, or Hawaii, where everything comes from somewhere else? Is it worth knowing where this kind of algae comes from, or what its home range is per se, or do we do that with algae?
So that's a really good question, and it is helpful to understand the point of origin for several reasons, to understand how the vector and how that organism arrived to Hawaii. That'll aid in future prevention, but it will also help us understand what are the natural predators in its point of origin. And so if we have clues as to what those predators may be, and then, if we do have any kind of mimic in Hawaii, then, we might be able to take advantage of a natural, predator that's much preferable to, divers going out and removing, either by mechanical or, in the extreme case of that chemical removal I talked about.
Right. Okay. Well, thank you. Have you all had the opportunity to do that for this species or the related species in the same genus? I'm sorry, figure out the vector or point of origin.
So, for the vector, we're pretty sure it came in on a vessel to Honolulu Harbor. Occurred in the entrance channel. It could have been. Oftentimes, the sea chests are a great place for a species to hide. Anchors, anchor chain, is a great place for species to hide. There's an example of a bunch of years ago when the USS Missouri been decommissioned, and it was sitting in the Columbia River up in Oregon, and it was brought down to Pearl Harbor, where it's showcased right now for the public. And shortly after it arrived, there were there were these mussels from Oregon that had attached to the hull, and no one knew that they were there. And so they were going through their death throes, and there was a mass spawning event. And the Missouri, if you've ever been on it or there, is right across from all the active naval submarine base in Pearl Harbor. And so that event fouled all the ballast chambers of the submarines, and it cost thousands of dollars to remove the spat from the submarine ballast. It was a major headache for the Navy. And so that's just an example of cost, for invasives.
Very good. Thank you for that example. All right, one last call for questions from anyone else on the line today. If you want to unmute your phone, just select *6 or send me a chat in the last few seconds here. Kevin, I'm not hearing any other questions right now, so we must have satisfied everyone's curiosity.
Super. All right. Well, thanks, Courtney, and thank you all for hanging in there. I appreciate the opportunity to talk to you. And shoot me an email if you have any questions, or give a call anytime. Happy to talk. And again, thanks, Courtney, for all your support.
You bet. Yeah, thanks for taking your time to share your work with us. I'm going to put your contact info up here on the screen for the last few minutes while people are still hanging out. And again, reach out to Kevin with more questions, and I hope you all can join us for another meeting in the future. Please just watch those announcements and feel free to invite colleagues. All right, you all have a great afternoon. This will conclude our meeting.